Hello everybody, welcome to the subject electromagnetic waves and transmission lines. In this video I am going to discuss about the wave equation in time harmonic. So this is a differential form of the Maxwell equation in time domain. Del cross E is equal to minus dou V by dou V by dou T. Del cross H is equal to J plus dou D by dou T. Divergence of D is equal to rho V. Divergence of D is equal to 0. So in time harmonic, these Maxwell equations are converted into time harmonic Maxwell's equation. Wherever there is a time derivative, that is dou by dou T, this time derivative, this differential operator is replaced by j omega. So hence the Maxwell's equations in time harmonic are represented, or it can be said that it is represented in phasor form also. That is del cross E is equal to minus j omega b, del cross H is equal to j plus j omega d. So then the wave equations for a source-free medium is given like this. For the source-free medium is where the charge density is 0, and the Maxwell's equation becomes del cross E is equal to minus j omega mu h, and del cross H is equal to sigma plus j omega epsilon into E. Divergence of E equal to 0, divergence of H is equal to 0. In the previous video we have discussed how the derivation of the wave equation. Just you are replacing uh, time derivative with j omega. Hence you got the final expression, that is del square E minus gamma square E equal to 0, where gamma square is nothing but equal to j omega mu into sigma plus j omega epsilon. So this equation del square E minus gamma square E equal to 0 in terms of magnetic field del square H minus gamma square H. These two equations are the wave equations for a conducting medium or a source free medium, which are called as Helmholtz equation. And this gamma here, gamma is the propagation constant, which is equal to, it becomes square root of j omega into sigma plus j omega epsilon. So now let us see in detail about the propagation constant gamma. Here the propagation constant gamma is a complex quantity which is measured per meter, and it is written as gamma equal to alpha plus j beta, where alpha is the attenuation constant and beta is called the phase constant, or it can also be called as phase shift constant or a wave number. So where gamma is nothing but, as we told, alpha plus j beta, which is equal to root of j omega mu sigma plus j omega epsilon. On solving this expression, we get the real part of the propagation constant alpha value, which is called attenuation constant. Here it is given in the expression, and beta value you are going to obtain this expression. So how to obtain this expression, how to solve this equation to obtain alpha and beta values, let us see here in detail. So we know that gamma equal to alpha plus j beta, which is equal to root of j omega mu into sigma plus j omega epsilon. First you square it on both sides and equate the real part and imaginary part. So the real part of the propagation constant is alpha square minus beta square is equal to minus omega square mu epsilon, and 2 into alpha beta is equal to omega mu sigma. From this beta will be equal to omega mu sigma by 2 alpha. You substitute the beta value in this equation and solve. On further solving, you get the value of alpha. So alpha is, that is attenuation constant, which is given as square root of this omega into square root of mu by 2 mu epsilon by 2 into square root of 1 plus sigma by omega whole square minus 1. And similarly in the same procedure, if you are going to solve for beta, you get the value beta is equal to omega root of mu epsilon by 2 into root of 1 plus sigma square by omega square epsilon plus 1. Okay, these are the values, general expressions for attenuation constant and phase constant. And the velocity, wave velocity is given as, we know that wave velocity of the wave is omega by beta. You substitute for the value of beta, you get this is the velocity of the wave propagating through any medium. Okay, and the wavelength is nothing but it defined as a distance through which the wave passes through the complete cycle of the 2 pi radians. So lambda is equal to 2 pi by beta. Substitute the value of beta here, you get this expression. And impedance of the medium, which has a finite value of the conductivity, this is given as root of j omega by sigma plus j omega epsilon. In later section we are going to derive this expression, but now it's not necessary. And finally, this is general expressions for all these parameters: velocity, as we discussed, omega by beta; propagation constant, attenuation constant, phase constant, intrinsic impedance, and wavelength. If you want to calculate these parameters, you can use these expressions. These are the general equations of uh, any kind of medium. Now, suppose if the medium is a good dielectrics, if it is a good dielectrics, that means sigma is very less than omega epsilon. I didn't mention here, but sigma should be, the conductivity is very less than omega epsilon. That is, sigma by omega epsilon will be very, very less than unity. So, this ratio is neglected here. On simplification, here on simplification, by neglecting the higher order terms, you get the alpha value. Alpha value is equal to sigma by 2 into root of mu epsilon, and beta value, this is the beta value you can obtain, and omega by beta gives the phase velocity when the wave is propagating through the good dielectrics. And on simplification, the wave impedance is we are going to obtain is root of mu by epsilon into 1 plus j sigma by omega epsilon. You can observe here this omega root beta is equal to omega root mu epsilon. It is the phase constant when the wave is propagating through the free space, and this eta is equal to root of mu by epsilon. This term is the free space impedance. So when it is propagating through the good dielectrics, so this is the amount of 1 plus in phase constant 1 plus sigma square by 8 omega square epsilon is the amount of change in the phase constant, and the wave impedance 1 plus j into sigma by j omega epsilon is the change in the impedance. And for good conductors, sigma is very greater than omega epsilon, or the ratio here sigma by omega epsilon is greater than unity. On simplification, you get the propagation constant for a good dielectrics is root of j omega mu into sigma, where root j is nothing but it is 45 degrees in angle in polar form. Root of omega mu sigma into 45 degrees. On simplification, this 45 degrees can be written as cos 45 plus j sin 45. So 1 by root 2 plus j 1 into 1 by root 2 you are going to obtain, and equate the real part and imaginary part. In for good conductors, the all attenuation constant, real part and imaginary part of the propagation constant both are equal, and therefore attenuation constant, phase constant for the good conductors have the same value, which is equal to root of omega mu by omega mu into sigma by 2, and the intrinsic impedance of for the good conductors is root of j omega mu by sigma. So this is the summary of all the parameters which we have defined here. For free space, that is conductivity is 0, epsilon r and mu are equal to 1, and epsilon will be equal to epsilon naught and mu will be equal to mu naught. Then the velocity in free space will be v is equal to 1 by root of mu naught epsilon naught, which is equal to velocity of light. And the propagation constant here, conductivity is 0, and this reduces to j omega root of omega naught epsilon naught. That means here when the wave is propagating through the free space, the propagation constant is purely imaginary, because alpha will be equal to 0. You can see it is a imaginary term, it is purely imaginary. And so alpha is equal to 0, and beta will be, phase constant will be omega root mu naught epsilon naught, or simply I can write it as omega by c. And intrinsic impedance will be equal to free space impedance, which is equal to 120 pi, and the wavelength lambda is equal to 2 pi by beta, which is equal to 2 pi by omega root of mu naught into epsilon naught. And if it is a perfect dielectric, as I told you, sigma by omega epsilon is very less than 1. Perfect dielectric, sigma is equal to 0, and mu will be equal to mu naught mu r, epsilon will be equal to epsilon naught epsilon r. So the velocity of the wave will be equal to c by root of mu r into epsilon r. If it is a non-magnetic medium, mu r you can take it as mu r equal to 1, and this becomes c by root of epsilon r, which is equal to omega by beta. Propagation constant for a perfect dielectric is alpha plus j beta, where perfect dielectric here attenuation is 0, and phase constant beta is equal to omega into root of mu naught mu r epsilon r, and the intrinsic impedance is equal to 120 by root of mu r by epsilon r. That means all these parameters are reduced by root epsilon r, and the wavelength 2 pi by omega beta, which is equal to you can substitute the value of beta here. and electromagnetic wave in a good conductor is very greater than 1. So if it is very greater than 1, these are the values as we discussed earlier. Okay, thank you. In next class we'll discuss about skin depth.